Okay, Ms. Howard Chemistry, this is Chemical Reactions and Balancing Unit 8, Part 2. And we still have the Texas Essential Knowledge and Skills 8C, 8D. So you're going to calculate the percent composition in empirical molecular formulas. You're going to use the law of conservation of mass to write and balance equations. C7, A, and B is never going away. Write and balance, write and name formulas and compounds. And you're going to differentiate between chemical and physical changes and properties. C8A, define and use the concept of the mole, so the mole stuff hasn't gone away either. And C5B, use the periodic table to identify and explain the properties of chemical families. Alright, Roman numeral number 2, find that on your notes. Chemical equation. Now that chemical equation uses symbols and formulas to show the IDs and relative amounts of the reactants and products in a chemical reaction. So we're still on Roman numeral number 2, and we left off on capital letter B. That chemical equation, it's a symbolized statement of the chemical reaction. It's just a nice shorthand way to write out the chemical reaction and what's going on. And it's quantitative. It's like a recipe. We can use those numbers, the coefficients, the big numbers in front, to show us relative amounts. So they show us ratios, how much of the one substance and how much of another substance you have to have so that they'll react. Another way we can look at those coefficients is to look at them as moles. Because remember, if we look at them as moles, we know that it links up to the atomic mass on the periodic table. So if I have 1 mole of a compound, I can calculate its formula mass, and I can go measure that out on the scales. So it makes it really practical again. Okay, capital letter D, you must follow the law of conservation of mass. That's the whole thing about balancing equations. You have to follow the law of conservation of mass because that's reality. So, again, number 1, mass or matter can neither be created nor destroyed, just change from one form to another. So a lot of times we say a law of conservation of matter, or they call it the law of conservation of mass. Same thing. Okay. Number 2, that means that the reactants, the mass of the reactants on one side of the equation has to equal the mass of the products. So if you start out with 20 grams of stuff, you have to end up with 20 grams of stuff. It may not be the same stuff. It may not look the same. It may not be in the same state, but you still have 20 grams. You can't lose some grams out of the universe, or even gain or create some grams from the universe. You are not God. Okay, capital letter E. You have to represent all substances involved in symbol form. That's what we learn those symbols for on the periodic table. The formulas must be written correctly according to those oxidation numbers. You remember on your yellow pages, the star reference materials? I do not want to change the color scheme. I don't know why it does that. It just vexes me. Alright, so you have to write the formulas correctly. Now, we've learned how to write the formulas, and it's not an easy thing. It just takes a lot of practice, though, to make sure you're doing it right. We know the oxidation numbers. You know also that the oxidation numbers are on your star reference, your yellow pages also. Okay, capital letter F, physical states. You can indicate whether the product or the reactant is a solid, liquid, gas, or it's aqueous. Aqueous, same thing. Alright, so the physical states, S would be solid, L would be liquid, G gas, and AQ means it's dissolved in water. It's aqueous or aqueous. So if you have an aqueous solution, then all you have to do is evaporate the water, and you should have your substance, that precipitate that formed, or whatever substance you have dissolved in the water should be left over in that. So if you have salt water, and you want to get just the salt, just evaporate the water. Heat the water off, and what you have left would be whatever was dissolved in that water. Capital letter G, the yield sign. That's the arrow. It's called a yield sign. It indicates that a reaction has occurred, and it shows the direction of the reaction. At this point in your chemistry career, we're typically only seeing reactions going in one direction. We usually see the arrow pointed to the right. You may see a few later on where it'll show equilibrium. It can go back and forth, but we won't see a lot of those in the regular chemistry class. So we have the yield sign, and letter H are the coefficients, and those are the big numbers that are in the front of each of the formulas. So they indicate the amount of reactants, the amount of the product. So if you look in the parentheses there, it says coefficients show the smallest numbers of moles of atoms that will satisfy the law of conservation of mass. So we can look at them as moles. And so you won't typically see like, 1/2 CO2. They don't put fractions or anything like that. Usually you have nice whole numbers, no decimal numbers either, so nice whole numbers there. Those are the coefficients. And notice it says that it's the smallest number of moles of atoms. It's got to be simplified. You know how you in math class you say it will reduce or simplify? Once you've balanced an equation, you need to check all the coefficients in front of all the formulas and see if they can't be reduced or simplified. Okay, capital letter I. How to write an equation. 1, write the word equation. In many cases when we start off, the word equation is what you start off with, and then you have to write out the symbol equation from that. So if you don't start with the word equation, you typically have to write one. Number 2, write the unbalanced equation, making sure that all the formulas are correct. That's huge. So you write the formulas down, and you have to use your oxidation numbers, your ion charges, and make sure that the formulas are written properly. Remember, we used the little crisscross method to do this. And then number 3, you have to balance the equation by adding coefficients. Once you have properly written the formulas, you don't mess with the subscripts. The little bitty numbers that are on there, you don't mess with those again. Letter J. From the coefficients in a chemical equation, you can find the masses of the reactants and products. Remember, the coefficients can stand for moles. We have 1 mole of this plus 2 moles of that yields 1 mole of this substance and 1 mole of this other substance. We can take those coefficients and we can say, hey, that's 1 mole. I can figure out how many grams that is. We just take moles and convert it to the mass by using the formula mass from the periodic table. Now, so for example, when you have H2, it's in a gas form. You guys know hydrogen is a gas. Plus Cl2, that's also in a gas form, and you produce HCl. And you notice it's a balanced equation. So if you look at that, we have 2 H's on the left, and let me see if I can just, right here, and we have 2 Cl's on the left, and when you end up over here, we have 2 of the HCl's, right? That's like writing HCl, HCl. If we write HCl, HCl, we have 2 H's and 2 Cl's. Notice that it's aqueous or aqueous. How many grams of each are present? Well, let me just plug in my spiffy little bamboo here. And when we look at this, okay, it better not screw things up because I won't be happy. I will not be happy. Whoa, let's make it a pen. Okay, so we have hydrogen, and if there's no number in front, it means there's 1. So we have 1 mole of H2. I make my little dimensional analysis grid. I've got 1 mole on bottom is equal to the formula mass of H2. Notice that there are 2 of the H's. 1 H is 1 gram, so 2 H's is 2 grams. So the hydrogen, 2 times 1 is 2. The hydrogen, we have 2 grams of hydrogen. Okay, my moles cancel out, right? You guys vaguely remember this, yes? Okay, if I look at the chlorine, I've got 1 mole of Cl2. How do I know that? Because if I look right here, there's no number, which means it's an understood 1. So I have 1 mole of Cl2, and that means I've got 1 mole. I'm going to convert it to grams, and I look at my periodic table, and chlorine has a mass of 35.5, right? But I've got Cl2, so that's actually 71 grams. So 1 mole of Cl2 is 71 grams of Cl2. So what's 71 plus 2? That should be 73 grams total on this side, right? On the left-hand side of the arrow. So what I'm going to do next is say, all right, that's an ugly arrow, isn't it? Let's make it prettier. Oh, I have all the time in the world to do this. Yes, I do. You have nothing better to do but sit there and take notes. All right, so I've got 73 grams on the left-hand side of the arrow. I better have 73 grams on the other side of the arrow because that's the law of conservation of mass. That's what it says. So it says I've got 2 moles of HCl, so I write that down. I've got 2 moles of HCl. Draw my grid here. 1 mole of HCl is equal to how many grams? Well, Cl is 35.5 and hydrogen is 1 gram, so that would be 36.5. What is 36.5 times 2? Oh my gosh, that is 73 grams. Oh, 73 grams on the left and 73 grams on the right. We have successfully proven the law of conservation of mass. That's how it works, all right? So all that stuff you learn about moles and how to go from grams to moles and so on, we're still using it right now. Okay, C8D, use the law of conservation of mass to write and balance equations. And you're finished with part 2.